Hi guys, and welcome to another lesson which we'll be covering how to integrate with other languages, programming languages. The normal Python distribution that we have been using until now is written and built using the C language and is often referred to as CPython. There are other implementations of the Python language in other languages. These non-C based interpreters facilitate integration of the other language with Python. Two of the best known of these alternate Python versions are Jython, written in Java, and Ironpython, an implementation for Microsoft's .NET environment. A third alternative is Cython, which is not strictly an implementation of Python, but a very closely related subset that can be compiled into C to provide very fast performance while still providing the speed of development of a Python-like language. Finally, it is possible to access Tcl Tk code from within the Takinter package. So let's talk a little bit about Jython. The Java implementation of Python offers many advantages to Java programmers looking for an interactive environment in which to test their Java classes to build prototype solutions that can, if necessary, be converted to full Java later. The distribution includes both an interpreter and a compiler. The interpreter comes with the familiar interactive prompt, as well as the ability to run scripts directly. In addition to importing Python modules, including many of the regular Python standard library modules, Jython can import Java libraries, making classes available to the Python interpreter as they were regular Python classes. This makes it possible to exercise and test new Java classes interactively at the Jython prompt. Jython also enables dynamic prototyping of solutions by mixing Java and Python code together. The interpreter can also be used to run script files with all of these same features for bigger projects or prototypes. The compiler takes Jython code, either pure Python or a mixture of Java classes and Python code, and compiles it into a .java file. This is a powerful tool for prototyping new classes because they can be developed and written in Python, compiled, and included in Java code. Once proven, the Python version can be seamlessly replaced with a pure Java version. The downside of Jython is that it tends to produce slower code than pure Java, and it's also more memory hungry. This is largely due to the fact that the compiler effectively embeds the Python interpreter in the output files. At the time of creating this course, Jython is at version 2.7, although work is underway to migrate to version 3. Then we have Ironpython. That is a version of Python written for the Microsoft .NET framework. .NET is not a single language system, rather it depends on a common bytecode to which several languages can be compiled. The modules so produced can then be shared between languages. Thus, code written in Ironpython can import modules written in C#, C++, Visual Basic, and several other .NET compatible languages. Similarly, Ironpython modules can be imported by any of those other .NET languages. Ironpython is an extremely appealing prospect for developers working on the .NET platform. Better still is the fact that an open source variant of .NET called Mono has been produced that can run under Linux and Mac OS X and many others, including mainframe computers and games consoles. This is achieved while maintaining binary level compatibility with the Microsoft.NET implementation. At the other end of the spectrum, a slightly limited version called Mono Touch runs on iOS and Android for building smartphone apps. As .NET becomes the de facto standard for building applications on Microsoft Windows. The availability of Python within that framework is a major boon for Python programmers. The Ironpython implementation supports most of the standard Python library as well as the .NET module system. Modules in .NET are called assemblies, but they are imported into Ironpython in exactly the same way that ordinary Python modules are imported. Some issues exist due to the dynamic typing used by Python and the .NET type system, which is more static in nature. However, once understood, these can be worked around using the helper function features built into Ironpython. So definitely check out the documentation that is provided on the Ironpython version. And then we have the CPython. CPython is significantly different from the other language integration options discussed. It is in effect a separate language from Python, but is highly compatible with it, describing itself as a superset of Python. This means Python programmers can easily learn Python and take advantage of its special features. So what are these features that would make you want to use Python? In short, speed. Python is a compiler that produces C code that in turn can be compiled to native machine code and thereby has the potential to run much faster than its Python equivalent. This compiled code can then be imported back into regular Python just like any other module to provide the best of both worlds. Easy Python development combined with C-level speed of execution. The Python extensions are mainly geared around interacting with native C code, and in this regard are similar to the helper features of the C types module discussed in the section accessing native APIs with C types and PyWin32 back in section 2. So one note is that if your Python code consists of importing a module that is already written in C and executing its functions, converting your program to Python will have little performance impact, but if your code contains a lot of pure Python processing, the difference can be significant. Python is not the only Python to C translator, but it is probably the easiest to use for the average Python programmer. You can find the Python website at python.org. And the last part for this section is the Tcl Tk. The Tkinter and Tix GUI modules are built on top of the Tcl/Tk and Tix tools kit. As such, they have the ability to execute Tcl code from within Python by using a method of the embedded Tk object, which is self.tk.call. So this method is the key to how the Tix module is built. So if you look at the code in the tix.py, you will find many method definitions that looks like an example from the notebook class. So the method is simply a wrapper for a call to the underlying Tix widget. So if you are familiar with the Tcl/Tk and Tix, you can fairly easily extend the existing Python widgets to utilize some Tcl features that are not otherwise available. But the integration does not need to stop with GUI widgets access. You can pass arbitrary Tcl code to the eval method and have it execute by the embedded Tcl interpreter. These could include importing Tcl modules that provide features that Python does not. Of course, you need to know Tcl to use this effectively. So definitely check out the documentation for Tcl. /tk.